All right, let's get started. Thank you all for joining us today for this webinar on basic statistics using Origin and OriginPro. My name is Ishwar Iyer. I'm product manager at OriginLab. We have two webinars today. After this one, at 2 p.m., we have an advanced statistics webinar. So I would highly recommend that you watch that one as well. If you haven't registered yet, you can still register. If you cannot make it to the 2 p.m. webinar, we'll be putting up the recording so you can look at that later. So this way, by reviewing both, you'll get a much better idea of the statistics capabilities in Origin. During the webinar, feel free to ask questions. You can use the Q&A window to ask specific questions. A few of my colleagues have joined from tech support. They will be answering. I will monitor the Q&A as well and try to answer as we go along. You can also use the chat window for general comments. If I'm going too fast or you want clarification or something, you can post there. Okay. So let's get started. So before diving into the tools, I have some general remarks about statistics capabilities in Origin and OriginPro. So you get a broad perspective of what's available. So to begin with, let me go to our website. So I am at originlab.com. Okay. And under the products menu, let me choose Origin. So this is our main product page. It basically gives you a very good summary of what's available in Origin and OriginPro. On the left, you will see there are all these different feature categories. So if I jump to statistics, there is a statistics section, but there is a read more. If I click on that, it will go to a specific page, products, Origin and OriginPro, statistics. You may want to bookmark this once you get there. It can be useful. Okay, somebody mentioned they cannot hear me. So recently we have had some reports about that. In WebEx audio, you may have to manually click connect to audio in the WebEx control panel in order to hear. Okay, this is not a common problem. We have had some customers mention that. So whoever has a problem with it, please try going to the panel and turning on connect to audio. Okay, so this page, products, Origin and OriginPro statistics, is very useful. It gives a very good summary of all the different areas that Origin and OriginPro covers in terms of statistical features, descriptive stats, ANOVA, parametric hypothesis, non-parametric tests, multivariate analysis, survival analysis, power and sample size tests, ROC curve, and last but not the least, we have been adding many apps for Origin. Maybe you're already familiar with apps. I'll be showing a few of them. My colleague James Chen, who will do the second webinar at 2 p.m., will be covering more of the advanced features, and he'll show some apps as well. So we have several apps that are specifically for statistical analysis, and these are free. They usually have a minimum version requirement, and some of them are pro only. So in general, if you have OriginPro, you have much more capabilities built into Origin. And in this page, we have clearly marked which are the pro features. So for example, this t-test on rows, many of the advanced areas such as multivariate analysis are all pro only. If you have Origin version, you could upgrade to pro. You can contact our sales department about that. Okay. Now, within the product, we have menus for statistics. We have apps. As I mentioned earlier, there is an apps bar here. You may already be familiar. You can add apps here. There is a button to click and try to add apps. And then you can go to the search panel, okay, or the new and popular tab. And so, for example, here I can go and type stats and search to show all the statistics apps. Then you will see there are several here. Some of them I have already downloaded, the green check mark. Some of them I haven't yet downloaded. For example, log histogram, forest plot. It's as easy as just click the button to download. Okay, and that will then get added to your collection here. So I just added log histogram. Okay. We have a search button in Origin. Maybe you're familiar with that. This was introduced several versions ago. If you click down here on this big red button at the bottom left, similar to the Windows button, you will see an edit box. You can type things in here. So for example, frequency. If you type in frequency, it will show you. There are several, maybe I should type frequency count. Okay, so you can see there are apps for frequency count. There is help pages for frequency count. You can also type a letter in front of your search string, and that can be customized. There are different letters to only focus on certain areas. So A for apps, H for help, and such. So this is a quick way to find what's in the product. So for example, I can say M for menu and frequency. Then it will show me all the frequency count menus. They're all grayed out because I don't have a worksheet active. If I have a worksheet active, they'll be clickable. So discrete frequency, frequency counts, 2D frequency, and such. Or I can type A for app, okay, and find all the apps that are related to frequency, okay. So that's a very helpful resource as well. And then in addition, we have tutorials, we have blogs, and we of course have our excellent tech support team. You're always welcome to contact us for specific help with your analysis, okay? So there are many different resources. So please keep in mind all these resources available to you when you are trying these features, okay? That said, let's jump into some of the basic statistics features. So my mission here is to cover quite a few of these basic statistics tools and apps in this first webinar. And as I mentioned, there will be a second webinar at 2 p.m. for advanced statistics, okay? So let's start out with some very basic things. I have a worksheet here with many different columns of numbers. So what if I want to get quick statistics on data in a worksheet? I can simply click a column and you'll see at the bottom in the status bar, Origin shows the statistics, average, sum. Maybe the font is not big enough for you to see, but there is a statistics area in the status bar. I can right click there and I can choose other quantities. For example, turn on min, turn on max, turn on standard deviation, okay? If I do that, then it will update and show me all those quantities. I can also right click there and I can copy the statistics and paste it elsewhere, such as in my lab notes, okay? And this works even if you do like a selection of cells, not just a column. You can also do non-contiguous selections, such as holding the control key and selecting something, and then the stats will update, okay? So that's a useful, quick way to get some statistics, okay? Now let's move on and see what if I want to display statistics for all these columns so that I can view them in my worksheet. So for that, I can go to these label rows. As you know, Origin has these label rows such as long name, comments, units, and such. If you click on the top title bar, you can go to view and turn on and turn off the standard rows. Okay, so there are spark lines, there's f of x for the column formula and such. Let me turn on spark lines. So spark lines are on. Then I can go select all the columns. And in recent versions of Origin, we have this mini toolbar that pops up. I can click and select the add sparkline button, okay, to see a quick view of the data. Of course, maybe viewing this data in this format is not helpful. So I can go to the column menu and I can choose the add and update sparklines to bring up the sparklines X function, the dialog. Over here, there are several options. One option is histogram. So if I turn that on, then I can see the data as a distribution. Just to get a rough idea, how is the data distributed, okay? Is it skewed? Does it look a little bit more normal? Of course, we have many tools for normality tests and distribution fit and such. I'll come back to those later. Okay. So that's one way to visualize the statistics of columns of data. Now in the same area, I can right click and say add user parameters. You can add your own user parameter rows. So if I select that, Origin comes up with the dialog, and I can pretty much type in any expression here, okay, such as min, max, whatever. But we have provided a bunch of most used quantities. So for example, if I want mean and standard deviation of the columns to be shown, I can choose mean, add, okay, and then I can go click again and choose standard deviation, okay, and click add. You can see those rows, label rows are being added. I can choose min, add, and I can choose max, okay, add, and click OK. So now I have all those rows. Those are showing the statistics for me, okay. I can format these. These are all strings. Essentially, the computation is done and displayed as a string, but I can choose multiple rows here, right click and say set user defined styles and click more, okay. And then I can go in here and I can say change to my specified decimal places, use 2 decimal places, for example, font size, font color, etc. Many things can be customized. So now it's more readable. So I can quickly read off statistics. I can see that the mean of CC under seg1 is 6107. The mean of CC under seg2 is 6168. The mean of CC under seg4 is 6854. So I can see the numbers quickly, visually in my worksheet. And keep in mind, if the data changes, I don't have another data set, so I'm just typing in some fake numbers here. You can see as I type numbers, the sparkline changes and also the computation changes. So whatever is shown here, these are all live. They are updated when your data changes. Any questions so far? Please feel free to type questions in the Q&A window or in the chat window. Okay, I'm monitoring them and my colleagues from tech support are looking at them as well. Okay. Okay. Another quick way is also to look at the statistics in the script window. So if you are into scripting, somehow WebEx is blocking my view of, let me see if I can auto hide it. View. Okay. Let me open the script window. So if I go to the window menu, I can open script window. Okay. Let me maximize Origin to go back. Now with the script window active, I can go do statistics on a particular column. So I can say, for example, stats on column 2 or column B. Okay. Then I can say stats dot equals, and it'll give you all the numbers. I can do quantiles column B. Okay. And type in quantiles dot equals, okay, to get the min, the max, the median, and such. So that's another way to get some quick statistics on your data. Okay, please feel free to type questions. Okay, moving on. Let's now get into stats on columns and rows. Okay. Okay. So here in this worksheet, I have some data, height and weight as a function of age and gender. Let's see how I can do basic statistics on columns, okay, with grouping based on, say, gender. So to show this, let me also show you a cool tool called Stats Advisor in Origin. So when you have a worksheet active, you can go to the statistics menu, and this is where all our statistics tools are housed. You can see there are quite a few, and then there is also a find apps, which will basically open that app center dialog that I showed, and it will look for statistics apps. And below here is all the tools I recently used, what we call our most recently used items. which is available under most menus for quick access. So if I had done a two sample t-test recently, I can just click there rather than having to find it. Keep in mind, I can also go to the the search button on the left and quickly find a menu item. Let me fire up the Stats Advisor. The idea here with the Stats Advisor is that it walks you through to find the appropriate tool or the app. I'll show several examples of this. So let me start with a very simple example. What I want here is to summarize this data, height and weight data as a function of gender. So I choose in the first column, what do you want to do? I want to summarize. Over here it says, what are my options? Basic stats, bin and frequency, outliers, graph for counts and percentages. I just want basic stats. So on the right side, it immediately tells me these are the tools available. I have stats on columns, I have stats on rows, I have pivot table, a box chart, I have means plot, I have forest plot. So these are apps, cluster gadget, statistics gadget. There are several options. Okay, so this is a useful tool to go to see, I do not know what's available in Origin. Let me see what I can do. And if you have standard Origin, the Pro entry will be shown, but it will be grayed out. So you also get an idea of what you are missing and you may want to switch to Pro. So let me choose stats on columns. So basically there's a description here, perform descriptive statistics. You can even open the help file or you can open the dialog. Okay, so I'm just simply opening the dialog. And from the dialog, I can say my data range. I can go out and hunt in my worksheet. Let me just move the stats advisor out of the way. I want to do stats on height and weight. Okay, come back to the dialog. Then I want grouping. So let me see, I want grouping based on gender. Okay, there's weighting range. If you have weighted data, you can assign a weight as well. Let me just click OK for now. So then Origin creates a detailed report similar to, let me just close the stats advisor. Okay, similar to how you get reports from linear regression and any other such tool. So here we have a detailed table. The table now has the summary statistics on the mean, the standard deviation as a function of, as a group based on female versus male for height, female versus male for weight. Okay. It also gives you what we call a flat sheet, a regular sheet. So if you want to do any plotting, you cannot plot from the summary sheets, what we call as report sheets, but in this case, you also have a flat sheet, so you can go do post analysis of the numbers from there. As you know, anytime when there is a lock, the lock says there is an input and there is an operation, there is an output. It basically ties the input to the output through an operation. In this case, the operation is stats on columns. I can click on it and I can do change parameters. So I can go see what are other options. There is computation control, there is quantities to compute. You can choose what descriptive statistics and quantiles you want to report. You can go to plots option and turn on histogram, okay, and turn on box charts and click OK. Now in my report, I'll also get graphs. So now I can double click and see what is the box chart of height for female versus male. Okay, and what is the box chart for weight distribution for female versus male. Okay, so this is quite a useful tool for doing descriptive stats on columns. Any questions? Okay, let's switch to another example. Over here, I have replicate measurements from a dose response study. So I have dose here in column A, and I have 3 different measurements, response 1, 2, and 3. Of course, Origin can fit the raw data without doing any summary, but sometimes you may want to do a mean and standard deviation and fit with it. It's your choice. So what I want to do in this case is take this row, all entries in this row, do the mean and standard deviation. Take all entries in the next row, do the mean and standard deviation. So I select all the rows. I can use the stats advisor as you saw before, but let me just quickly go to descriptive stats and go to stats on rows. Okay, and open that dialog. Sorry, something is hiding my menu. Statistics, descriptive stats, stats on rows, open dialog. Okay, so then in the dialog, again, similar to stats on columns, you have quantities that you want. I can turn on everything and turn off as a quick way to turn everything off. Then I can choose mean and standard deviation. Then I can collapse the moments and open quantiles. I don't really want any quantiles and simply click OK. So now I have my mean and standard deviation. So now I can take this data, I can create a plot as a scatter plot. Now you see the data is plotted as a symbol with error bars using the standard deviation. Now I can do a logistic fit or whatever it is I want to do with the data. I'm not going into the fitting in this session. I'm focusing on the statistics part. Okay. So far, so good. Any questions? If you have questions, please put in the Q&A panel or put in the chat panel. Please don't try to raise your hand or communicate with me in another way because I may not be able to monitor that. Okay. All right, moving on. When data is plotted in a graph, Origin has a selection of tools that we call gadgets. Okay, they are essentially for interactive analysis. So here I have some data of automobile gas mileage as a function of power. Okay, lower the power, higher the gas mileage. That's the general trend here. So one can do linear regression with this and so forth. I'm just going to use this data and go to the gadgets menu, and I'm going to choose the statistics gadget. And then the statistics gadget has a flyout. I can either open the dialog or I can choose this predefined theme, mean plus 1 plus standard deviation. So when I do that, it puts on a region of interest on my graph. Okay, then I can move this region of interest around. That's the general idea with gadgets. You can select part of your data. So I can go collapse this and say, what's my mean and plus minus 1 standard deviation for data where the power is below 100 kilowatt. Then I can move it to above 100 kilowatt. Okay, to see the numbers. So exploratory analysis of graphs and the data to get some quick statistics. You can see that the statistics is shown above. You can click on this button to open the preferences dialog, and there are many options there. What to show on top? Do you want to show the X-min, X-max, sum? And so you can choose a few more things and click OK. And then those quantities will be reported on top as well. Okay. In the Pro version, we also have a cluster gadget. So let me show that. Under the same gadgets menu, I can choose cluster. And this is a bit more sophisticated than that other rectangular ROI. Here I can choose a circular ROI and click OK. And also here I can position it arbitrarily anywhere on my graph. So here I have some measurement of the efficacy of different drugs. And there seem to be some clusters here. So I can go examine like what is the recovery rate for this cluster. Okay, what was the mean? That was 41.83. Okay, then I can move down to this cluster and see the recovery rate was 20.5, mean, and so on. Okay, so this is a useful tool. There are many other options in this tool. I'm not going to go into all of those. You can mask the selected points. You can extract them to another sheet and such. So this is quite a versatile tool if you want to do statistics on arbitrary regions of data in a graph. Okay, questions? Okay, moving on. So now here I have a graph with data plotted. It's just some random data. I have used a formula to fill the data here. Let me show you that. If I hold the Alt key and double click on this button, it'll open a dialog. So basically you can put a text object on a worksheet and convert that to a button. Okay, there are tutorials on all of this. This is just a quick and dirty way of making a quick small interface. So I have an expression here. This is a laptop script that says column 2 equals nearest integer 50 plus 15 star normal 50. So I'm saying generate 50 normal numbers, okay, multiply by 15, add a 50 offset, and do nearest integer on that. So if I run this, you will see the numbers keep changing, right? So I'm randomly generating numbers. Also in Origin, there are many ways of generating such numbers. If you right click on a column, you can see there is a menu item called fill columns with row numbers, uniform numbers, normal random numbers, a set of numbers, a set of date time values, arbitrary set of text and numeric values. And we also have a couple of cool apps, Data Factory and Monte Carlo app. You may want to check those out. Those are more versatile for generating numbers. In my case, I just wanted a quick and dirty list of some numbers to show you a nice feature with reference lines. So I have the data graph here. Now, if I click on the layer, in recent versions, we have this icon, the mini toolbar that pops up. Okay, that's fairly new. We introduced it a couple of versions ago. You can do what I'm showing here from the menu as well, but this is a quick way to access popular things. We populated this based on what customers typically do in their graphs. So one of the things we added here is add statistics reference lines. So if I click on that, this menu pops up, so I can add a mean line. So there is my mean. I can click and say add a +1 standard deviation. I can say add -1 standard deviation. Add min. Okay, sorry, I didn't choose that properly. Okay, add min and click again and add max. So now my graph is annotated with all of these lines that are showing me the summary of the data. Let me quickly grab all of these and move them a bit to the side. And I'm just going to reduce the font. Okay, so it's a bit more readable. Okay, there are tricks to do the formatting, such as show only 2 digits and so on. I'm not going into those details now, but I wanted to show you that this computation that's done for the reference lines is live. So if I change data, you can see my data changes and those reference lines also change. So the reference line takes the active data in the graph and does computation, and when the data changes, the results change. Okay, so this may be a useful tool for you to monitor some data, maybe plot different segments of your data and quickly see if they're staying within range or going out of your preset parameters or whatever. Okay, the reference lines are quite versatile. If I double click on the axis, you will see in recent versions we have added a reference line tab, and this is where my quick menu ended up adding all those reference lines. Let me pick one of them. I'm going to pick the first one, which is plus standard deviation, and if I click on details, a very detailed dialog opens. Okay, so basically a reference line can be set using a specific value, such as you want to value at, say, y = 0 or y = 10. You can use an expression such as y = ax plus b, where a and b are some constants, or you can use statistics. Okay, in this case, statistics what I used, but I did not have to come to this dialog. I could do it in a quick way by using the mini toolbars. Okay, so the reference lines are quite versatile. You might want to check that out for other expressions and statistics that you may want to put on your graph. Okay, questions? Somebody said stats gadget explanation not clear. I would recommend you to take a look at the tutorial, please. I do not want to go back to that. I would like to we are halfway through the webinar and I have quite a bit to cover. So we do have tutorials on videos on all of those. Okay. All right. So let's go to frequency counting. Okay. So here I have some data from NBA player statistics that I found on the web the other day. Player height versus player weight, which country they're from, which draft year, which draft round, where they're drafted in the first round or second round, and so on. I want to do frequency counting here on the player height or player weight. So let me choose one of these columns and let me go to statistics and descriptive statistics, and I'm going to choose frequency count. You can see there are a bunch of tools here: discrete frequency, frequency counts, 2D frequency count with binning. There are also apps for it. I'll show you one of the apps. So what I'm currently interested in is the frequency counts tool. So let me open that. And I want to change the settings here to say my data is indexed. So I have another column, other columns with properties here. So I have indexed data. So then I can say my data range that I'm looking at is player height, and my group range is draft round, which draft and does have, how does the height change based on that? Is there any change in the distribution? That's what I would like to see. So then the quantities to compute, I can go here and say, I don't want bin end, I don't want cumulative count, I just want bin center and count, okay? And click OK. So then you will see that Origin did the frequency count for draft 1 versus draft 2 versus draft 3 versus draft 4. Some of them don't have much data versus undrafted. So just by looking at this data itself, you can see there is some variation. Now, why did these come in a quirky order? Let me go back here. You will see that this column, if I right click, has been set to categorical, okay, but it has not been ordered in the order that I would like it to be. So I can double click here to the column properties dialog, and I can go to categories, and I can change the order to custom order. So I can say put undrafted on top, put draft cycle 1 on top, 2, 3, 4, for some reason 5 is not there, 6, 7. This is old data. I don't know if it's relevant for new NBA drafting procedure and stuff. I'm not familiar. So let's click OK. Then if you go here, you will see that this button turned yellow. That means the input data changed, but the output hasn't updated because it's in manual mode. As you know, operations in Origin can be manual, auto, or none. Let me change it to auto. So now you see it came in the order that I like: undrafted 1, 2, 3, 4, 5, 6. So let me choose undrafted and draft cycle 1. Then I can go to the plot menu and look at basic 2D, for example, and pick like a plot, like column plot. So if I do the column plot, you will see here is my profile of height of players, undrafted versus. So this is the height, that's the counts, okay? And I can make this graph nicer. In recent versions, I can quickly change the width of the bar and fill color and such using the mini toolbar. So you see there is quite a bit of difference. Like in the first draft, there is a bias towards the taller players, whereas if you look at undrafted, it's much broader, okay? Okay. Let's go back to this data and let me show you a couple of other tools. What if I want to look at the distribution of the player weight as a function of binning of player height? So this has come up often in tech support, okay? And we made an app for it, okay? Okay, so let me go to, somebody here commented that I'm going too fast. I'll try to slow down. Keep in mind that this whole thing is recorded. You can come back and watch it. You will get the project and you can play with it as well. So my objective here is to give you a broad perspective of the tools available. So if it seems a bit rushed, I apologize, but you can always come back to the recording, and tech support is always there to help, okay? All right. If many of you think I'm going really fast, please comment. I just saw one person here saying too fast. Okay. All right. So we added a 1D binning app recently. So let me show that. I have already installed it. It's in my app collection here. I click 1D binning. Then I can choose here what's my input. My input that I want to do the statistics on or rather I want to bin on is the player height. Okay. And let me choose, for example, I want the number of bins to be 10 bins. Okay. So simultaneously when binning on the height, I want to see how the weight of the players are distributed. So I can go here and say dataset to compute quantities on is weight. And I want the mean and standard deviation. Let me turn off the other things. Okay. And click OK. So this app is quite useful. So now it's showing me the distribution of player mean weight and standard deviation based on binning on their height. So looking at this data, I can see that the maximum count here is frequency count here of 3000 at a height of 204, and the mean weight for that group is 103 with a standard deviation of 8. If I go further away, the weight drops, and if I go this way, the weight increases. So that's a useful app. You might want to check that out. Okay. Okay. All right. Okay. Let me slow down some more because I feel I'm going fast, and somebody else also commented I'm going a little fast. Okay. Let's go back to this data. So I may drop some of the topics here. I may not be able to cover them. Let me go back to this data, and you can see in this data I have country information. So the players came from many different countries: USA, New Zealand, Russia, etc. Okay. So if I select that and go to statistics, descriptive stats, you see I also have a discrete frequency count tool. If I choose that and open dialog, you can see I can do counting, I can do relative frequency, and I can do it as a function of percent. Okay. There are many options in these kind of dialogues. You just click F1, you can read information on what these various controls do. Okay, I'm showing you some of the options. Okay, if I click, then I get a report here with the raw counts and the percentage. So you'll see that the most players, 84% came from USA, 1.3% from France, 1.25% from Canada, and so forth. So that's another tool. If you have categorical data, you can use a discrete frequency count to generate frequency counts. Okay. All right. Someone else is now complaining that I'm too slow. So I guess it's a tug of war between some complaining too fast, some complaining too slow. Okay. Let's move on. Now, this often comes up in tech support. Users have one column of data and they want to do a histogram and fit the histogram. There are pitfalls to doing that. So I took this data, I binned it two ways. I binned it using a smaller bin count, and I binned it using a broader bin count. And I fitted it using a Gaussian function. I'm not going into the details of fitting. I just did a frequency count that you saw before and fit them. The main point I want to point out here is that depending on the binning, you can see the centroid value and the sigma value can be different. So if you fit bin data, the fit results can be sensitive to the bin size. So it's not really appropriate to take a single column of data, bin it, and do curve fitting to it. Okay, we know customers do it all the time. They ask how to do it. So the way to do it is use the frequency count, do the frequency count, and plot it as a bar plot or column plot, and then you can do the fit. But a better tool to do this is to take the data, go to the statistics menu, descriptive stats, and choose distribution fit. We introduced that in somewhat recent versions of Origin. So if we open this dialog, what this does is it does a pure statistical analysis, not a curve fitting, not an iterative procedure. It looks at the raw data and tests what distributions are appropriate. So I can go to distributions and I can turn on multiple distribution. check normal versus variable versus gamma, for example. Okay, then there are several quantities to compute, variance, sum and such. Goodness of fit, I want to check the goodness of fit. You can use multiple methods here. Anderson, Darling, Kolmogorov, Smirnov. You can turn on plots, okay, and such, and click OK. So this tool does a rigorous statistical analysis of your data and then tells you, is your data normally distributed? So for example, the goodness of fit test clearly says, both KS and AD test says can't reject normal, which means it is valid to say this data is normally distributed. And these methods clearly say reject variable, reject gamma. Okay. Then if you look at the histogram, it shows you the result and the box chart. And more importantly, here are the parameters, the mean and standard deviation. So these are purely based on the raw data. They're not a result of fitting. So if you have a column of data which you think are normally distributed, you can use this tool to A, check is it normally distributed, B, get the mean and standard deviation, the sigma, rather than binning it and fitting it. Okay, just wanted to let you know this option is available. Okay, moving on. Please type questions. I don't see any technical questions that you're typing. Okay, somebody typed here multimodal distributions. That distribution fit tool currently does not have an option for multimodal distributions, but our histogram plot can overlay a curve. Let me quickly show you. So if I go back to my raw data, I can go to the plot menu and go to statistical plots and do histogram. There should be an option for here, histogram with overlay. I'm trying to find it. There is a, okay, distribution. So if I click that, it will take my data and throw a distribution curve on it. My data happens to be normal. But if you go in here in the plot details dialog, and if there is a distribution tab, you will see there is normal distribution versus log normal, etc. There is also kernel smooth, which is multimodal. In my case, of course, I don't have any other bumps in the data. I have only one peak. So again, this distribution curve is plotted purely based on statistics. It's not based on fitting, okay? We do not have a test for multimodal distribution. So I will bring that up with our R&D to see if we can add it to our distribution fit tool. Thank you for that question. Okay, let's move on to a few other tools, correlation. So I have some data here of protein consumption. So you may know that when you view a worksheet under the view menu, there is a column list view, which can be toggled using Control W. So if I use Control W, I can view all of my columns and the data. If I click Control W again, I see a summarized view. Okay, so here it's just showing me all the different columns. There is data on consumption of red meat, white meat, eggs, milk, fish, cereal, starch, nuts, fruit, and vegetables. I want to see, are these data somehow correlated? Okay, there are several tools for correlation analysis under the statistics menu, but better is to use a recent app called Correlation Plot that we introduced in 2020B. So let me show you that app. So let me fire up the app. The app lets you select columns. So let me choose all these columns: country, red meat, white meat, all of these columns. Okay. And then I can turn on an auto preview. It then shows me, sorry, I have to turn off country because that's not numeric data. So it shows me the correlation plot, how things are correlated. Obviously, the diagonal elements are all pure correlation of the same column against itself. But I can go here and change. I can say, show me an ellipse, show me layout where I have lower triangular versus upper triangular. Okay, I can go here and say, show me mixed. So then it will show you the symbols on one half and numbers on the other. I can again change this to ellipse. I can choose what label to show. I can show significance mark, correlation coefficient, p-value, etc. So if I, for example, put a significance mark, only the quantities that have a significant correlation using the significance level of 95% will be marked. So then I can click OK, and I get this really nice graph of correlation between my columns, right? So note that this way my diagonal elements are removed. It's annoying to just show correlation of pure correlation of 1 there. So now you can see there is a strong correlation between red meat and egg consumption. So the ellipse is slanted right side. That means there is a positive correlation. If the ellipse is tilted to the left, there is a negative correlation between red meat and cereal consumption. Okay, there is a weak correlation between red meat and starch and such. So an easy way to visualize multiple columns of data in a graphical way to quickly see where are my strong correlation among my multivariate data. Okay, there will be more examples of multivariate data later this afternoon in the advanced statistics webinar. Okay, all right. I don't see any more comments about speed, so I hope I'm doing okay. Again, this might seem like a rushed thing because I'm trying to show you a selection of tools. My goal here is to give you the idea, a broad perspective of what's available in Origin. You may not have thought of Origin as a tool for statistical analysis. Next time you have some data and you want to do statistics, before you fire up another product you're already using Origin, give us a try. You will be surprised on the amount of tools and apps that we have added. Okay, so my goal is to I wouldn't say shock and awe, just to show you what's available so that you get a broad perspective. Okay. Okay. Okay, somebody asked, how can you make those correlation plots if you do not have 2020B and 2018 version? So if you have data, there are correlation tools in the statistics, descriptive stats correlation. You can try that out. Also in the plot menu, there is a correlation plot under statistical plots. There is scatter metrics. You can try those. I just wanted to highlight the correlation plot app because it's a new plot and it was really very well received by customers. Okay. All right. All right. So let's look at outliers. This comes up once in a while. So I have some data here. The spark line shows that maybe some of the data points are outliers. So how to detect outliers? This becomes very subjective. Different fields have different requirements and accepted tests for outliers. I'll just show you a few variations. If I go to the stats menu under descriptive stats, there is a Grubbs test and a Dixon's test. So let me just run the Grubbs test, open, and I'll just accept the defaults and click OK. And I get a detailed report, and this report says at the 0.05 level, the lowest value 12 is a significant outlier. Okay, we take the same data. I'll go to the stats menu again and do the Dixon's test. Okay, and again accept defaults and run, and you can see this test also indicates the value 12 is an outlier. Okay, all right. If there are other methodologies for detecting outliers in your field, let us know. We are happy to look into it. Another way of detecting outliers is using studentized residuals. Okay, so here, earlier case, I had only one column of data. Here I have a dependent variable versus independent variables, and I have plotted it here. And this looks like an outlier. Maybe this is an outlier. So how can I tell? By doing a linear regression and using studentized residuals. Okay, so with this graph active, let me go to the analysis menu, go to fitting, go to linear fit, and open dialog. And I'm going to just accept most of the defaults, but I'm going to go under residual analysis and I'm going to turn on studentized residuals. Okay, and click OK. So the linear regression gets done, and here are my result values. Let me change this to automatically update when data changes. And let's go look at the report sheet. Okay, so here's my detailed report sheet of my fit parameters and such. And here is my table of all the residual values and the fit curves. If I look at this table, if I look under studentized residuals, you will see this value is way out, minus 2.6. So the way to detect outliers using studentized residuals is that if the absolute value of the studentized residual is larger than 2.5, then that point is an outlier. Okay, so clearly it's saying 0.6 is an outlier. Now I can go to the graph, and in the tools menu on the left, there is a masking tool. And click on this tool, come here, drag and select this. I apologize for that. Drag this particular point and mask it. And you see the fit automatically updated by leaving out this point. That's a nifty feature in Origin. Now, if I go back to the residual table and look, you'll see under the studentized residuals, there are no values that are beyond 2.5. There is one value that's very close to 2.5, which is this point. But by this test, it's saying you cannot really call that an outlier. Okay, so that's just another method. Again, it's really based on what is acceptable in your field. Okay, all right. Okay, a few more things to cover here. I have about 10 minutes left. Thank you for your patience and thank you for your comments so far. Please keep the questions going. Okay, t-tests. There are many different t-tests in Origin. I want to show you one example here. Okay, so in this example, I have measurements of zinc concentration in a water sample, and the sample was collected from the same body of water. One sample was from the bottom and one sample was from the surface, such as say lake. A sample was collected at the surface of the lake and the bottom of the lake. The objective here is to do a t-test to see, is there a significant difference in the mean between the sample collected from the bottom and the sample collected from the surface. Okay, to pick the right tool for this, let me make this sheet active and go to the stats advisor to show you again how the stats advisor can really help. So my idea here is to compare means, medians, variance, proportions in groups of data sets. So I select that. On the right side, it's asking me, what do I want to compare? I want to compare means. Then it's asking me, does the test assume data are normally distributed? In my case, the answer is yes. How many groups of data are there? It's one group with 2 levels. Okay. Then it's asking, do each subject contain 2 treatments, paired or not? So it's actually 2 treatments. Okay, because they're paired, they're from the same body of water. This is very important. If you say no, it will suggest different tests. You see, the advisor can only help you to pick the tool, but you need to have knowledge of the data. You need to be careful about the data and the conditions under which the data was collected. So if you pick the wrong answer in the advisor tool or pick the wrong tool from the menu, you will end up with the wrong statistic. So I just wanted to make that point clear. So in my case, it's paired data because it's from the same body of water, 2 different samples. So I had to choose yes, and it says use the pair sample t-test. So I can fire that up. I can open the dialog. Okay, and now I can choose my first data range is the bottom sample, and the second data range is the top sample. I can accept the other defaults and click OK. Okay, and let me go back here, close the advisor, go back here and look at the report sheet. Okay, so in the report sheet, it says at the 0.05 level, the difference of population means is significantly different from the test difference. If I had chosen the wrong tool, a regular t-test or paired t-test, then I would have gotten the wrong conclusion. I don't have time to show that, but you can try it with this data when we share. So it's important to know the condition of your data before you choose the right tool from the menu. Okay. All right. A couple more examples here before we close. So power and sample size. Okay, I have a study that I am putting together on the efficacy of drugs A and B, and I think this study will result in the drug A having an efficacy of 10 and drug B an efficacy of 6.5. These numbers are my estimates from some random trials that I did, and the standard deviation estimate on that data is value of 3. That's my estimate. Now the question is, if I want to do a successful trial with drug A and B, how large of a sample size, how many people do I need to recruit to make this study? Okay, so for that we have several tools for power and sample size analysis. So because I have 2 drugs here working on the same subject, I go to a 2-sample t-test power and sample size. So I go to the statistics menu, I go to power and sample size, and I choose the 2-sample t-test and open the dialog. And this dialog, of course, is not working on data, it's working on estimates. So I just have to put in my estimates, what I had typed in for reference here. So estimate for drug A is 10, estimate for drug B is 6.5, my standard deviation is 3, my alpha is 5, two-tailed distribution. And let's say, is 5 subjects enough? Is 10 enough? Is 15 enough? Is 20 enough? Is 25 enough? I want to find out. Okay, let me leave everything else as default and click OK. Then I get a nice report here where I get the power number and the sample size. And when you do a study like this, you are shooting for a power of 80% or higher. So this clearly says, given my assumptions of value of 10 and 6.5 and error of 3, I need to have about not 5, not 10, maybe 15. 15 is giving me 0.86. So that's a safe number of subjects to recruit for this study. Okay, just another tool in our vast collection of statistics tools. Okay. All right. Last one, a means comparison example. My friend James Chen later this afternoon will be showing many advanced tools, including ANOVA. Okay, he may show an example of one-way ANOVA. I'm looking at this data. This is nitrogen absorption in 4 different plants, plant 1, 2, 3, 4. And rather than doing an ANOVA in this simple session, I just want to make a quick means plot to see are the means significantly different from each other. So let me just select all these columns, and we have a nice app called pair comparison plot. Okay, this is a popular app. We have been doing many modifications to it based on feedback from users. So you may want to check that out. So let me go click that and fire it up. And my data is raw data. I have 4 different columns of plant 1, 2, 3, and 4. Okay, so let me select those columns, plant 1, plant 2, plant 3, plant 4. And there are several options here. What type of a plot do I want? Do I want a bar plot? Do I want a data point plot? Do I want p-value with brackets? Let me choose the defaults. And then how to perform the means comparison, a Tukey test or a Boniferoni test. You can choose your favorite model and click OK. And then you will get a nice plot. So this plot is showing clearly that plant 1, plant 2, plant 3 are similar. Plant 4 is significantly different in the mean. You can see, given the p-values, 4 is different from 3, 4 is different from 2, 4 is different from 1. I can click on the log and bring up change parameters, and I can change it to, for example, asterisk with bracket. Okay, that's a popular option. Then it puts these asterisks to mark significance, and then it shows here the p-value corresponding to the different markings. So here again, it's the same conclusion, just a different way of looking at the result. I can also do change parameters and choose letters on top. That's another popular option. So if I choose that, you can see clearly plant 1, 2, and 3 are marked with letter A, and plant plan 4 is marked with letter B. Okay. Okay. So my main message here is there are many tools in Origin for doing statistics, and I hope this basic statistics webinar gave you a rough idea of what's available.